Hi, welcome to the video on nuclear notation review. You should watch this video after you have completed the warm-up nuclear notation review. This video will go over those questions and also some key ideas that you covered in previous lessons. So as you likely know, there's 118 different types of atoms. We call types of atoms elements that you can find on the periodic table. And the last few lessons we were exploring a bit about atoms. So some of the things that we learned about atoms is that atoms are made up of three things: protons, neutrons, and electrons. And we call these three things subatomic particles. The protons and neutrons are found in the nucleus, which is in the center of the atom, and the electrons are found in the electron cloud, which surrounds it. In addition to their location, we learned a couple of other characteristics of protons, neutrons, and electrons. We learned that protons have a mass of 1 and a charge of +1. Neutrons have a mass of 1 but no charge, and electrons have no mass but a -1 charge. The other thing that we learned is that we can use the number of protons, neutrons, and electrons in an atom to determine some of the atomic properties, like atomic number, which identifies the atoms, and that's equal to the number of protons. Mass number, which describes the mass of the atom in a unit called AMU, or atomic mass units. And we can calculate the mass number by adding the protons and neutrons together, since they're the only ones that have a mass, protons and neutrons. And then finally, the last property is charge. That describes the net charge of protons and electrons, and we can calculate that by taking the protons and subtracting from it the number of electrons. You were introduced to this topic with the excellent atom activity, which essentially you saw the same things. We use different chips with the same characteristics of protons, which are the blue chips, neutrons, which are the red chips, and electrons, which are the green chips, to identify the properties of an atom, the mass, net charge. And then the last thing that we looked at was called the identity. And the identity is how we identify an atom using the periodic table. And for atoms, they're identified by their atomic number. So if you look at an element in the periodic table, you see that each one has a unique atomic number, and that's the number written on the top inside the box. That atomic number is equal to the number of protons, so if you know the number of protons of an atom, you can identify it. You also took some notes, and part of your notes you annotated that atomic symbol, which you saw. So the upper left number, which is your mass number, protons plus neutrons. The bottom number is the atomic number, it's the number of protons. The upper right number is the charge, which is protons minus electrons. In the middle, you have your element symbol. This matched what you did with the excellent atom activity, where you remember that the mass that you determined we put in the upper left box, the number of protons or blue chips we put in the lower left box, and the charge we put in the upper right box, and the element symbol we put in the middle. So let's take a look at the warm-up questions. So this first warm-up question is asking you to match the atomic properties to the correct numbers below. So we have atomic number, charge, and mass number. So let's start with the atomic number since that's first. Remember, that's the one in the lower left corner. So that would be 16. So I'll drag and drop that there. The charge is the one in the upper right corner, and that's -2. So I'll drag and drop that in there. And the mass number is the one in the upper left. So I will drag and drop that there. That's 36. So that's the first one done. So in order to answer this question, you have to remember sort of the structure of the atomic symbol, where the mass number goes, where the atomic number and charge go. Let's go on to the next question. So the next question says determine the number of protons, neutrons, and electrons in the atom below. This one's a little bit more tricky because we're kind of doing things in reverse. So for protons, that's pretty easy because remember the atomic number, which is the one in the lower left corner, that's the number of protons. So that will just be 16. So I can easily drag and drop that there. So whatever the number is in the lower left, that's the number of protons. They're equivalent. Now for neutrons, I have to do a little math because remember the mass number, which is 36, is equal to protons plus neutrons. Now I know there are 16 protons, but I just want the number of neutrons. So what I'm going to have to do is I'm going to have to take the mass number 36 and subtract from it the atomic number 16. So 36 minus 16 will give me 20 neutrons. Finally, for the electrons, this probably is the trickiest one. For this one, we're going to use two numbers. Again, we're going to use the atomic number, and you'll notice for all three of these we use the atomic number. But we're also going to need to use the charge. Now remember, the charge is equal to protons minus electrons. We know we have 16 protons here. And one way that we can figure out how many electrons we have is by doing a little math. We can do 16 minus -2. Now if you're subtracting a -2, that will be adding 2. So 16 plus 2 will give you 18. There are 18 electrons. So that's one way you can figure it out, by taking the atomic number, 16, and subtracting from it the charge, -2. Similarly, the way you can think about this is that you're using the atomic number and the charge, and whatever the sign is on the charge, you're going to do the opposite math. So if this is a -2, that means you would add 2. So 16 plus 2. Now the final way to do it is conceptually. Remember that electrons have a minus charge, a negative charge. So if your charge is negative, that means you have more electrons than protons. So that I would know that I would need 2 more electrons than the 16 protons I have. And either way, I would still get 18. So just to sort of recap that, when you're going from atomic symbol to number of protons, neutrons, and electrons, the atomic number, the one on the bottom left, would be the number of protons. So in this case, it would be 14. The mass number will be number of neutrons will be the mass number minus atomic number. So that will be the top minus bottom. So 30 minus 14. And that, in this case, 30 minus 14 is equal to 16. So this would have 16 neutrons. And finally, for the number of electrons, we would do the atomic number minus the charge. So 14 minus 2, or minus -2 in this case. And remember, if you're doing a minus and a minus together, that's the same thing as saying 14 plus 2. Which would, of course, equal 16. So we have, in this symbol, we would have 14 protons, 16 neutrons, and 16 electrons. All right, last question is, an atom has 4 electrons, 3 neutrons, and 5 protons. Which element is it? So I want to identify which element on the periodic table it is. So which subatomic particle or property has you identify the element? Well, remember, the one that you use to identify the element is the number of protons, like we did with the blue chips. So all I have to do is focus on the number of protons. I don't need electrons or neutrons to help me here. I have 5 protons, and what I'm going to do is I'm going to find the element with an atomic number of 5, since that's going to equal to the number of protons. So I look at my periodic table, and the atomic number is the number at the top inside the box. So I look for where there's a 5, and here it is. That's boron. So the symbol is B, and the element is called boron, so I can select that one. And then I'm done. I hope you found this video helpful. Have a quality day.